No, it's like in 1 hour, how many tons of how much heat it can absorb? It
We
can
can remove how
melt
much.
tons of ice.
Again, tell. I'm unable to hear you.
Ma'am, means in 1 hour it will remove how much amount of heat? Means 1,000 kilocalories or
Yes. But why is it? My question was, why is it related to ton? Why as this
Ma'am,
is
a ton of a ton.
actually this as the ton word has come from the earlier days where people have used placing people were cooling their room by placing ice inside their room.
Yes, ma'am.
Got it? So if you will put 1 ton of ice in a particular room and you will use 1 ton of AC, accordingly it is how much heat you will be extracting. And from there itself, this ton word has come. Understood, all of you?
can you repeat?
See, you forget about ton. You now consider about the bulb you are using. They are rated. They are not rated in ton. They are rated in watt.
What?
Okay. So now suppose you are having two options. You are having 1 watt bulb, another 2 watt bulb. What is the difference? What is the difference? Suppose you will use 2 watt bulb is better for you, or 1 watt bulb is better for you. Yes,
2 watt will be more brighter.
2 watt will be more brighter. Okay. See, that I am telling you, you cannot tell specifically that a 2 watt is better. There are different factors acting on it. What are the different factors? First thing is your cost. Okay, cost of the bulb, then consumption of the power, then your efficiency, then come to the lightning. All these factors are responsible. See, you cannot tell the 2 watt bulb is better. If you are using a 2 watt bulb, obviously it is giving you more because it is having more wattage. It will give you more brightness or more illumination. But at the same time, you are paying more electricity bill compared to that of the 1 watt. Am I clear to all of you? Am I clear to all of you? Yes. So there are different factors acting on it. You cannot just tell that 2 watt bulb is better. Yes, it is better when your brightness or illumination is considered into picture. Okay, but now I am telling you if it is a 1 watt and 2 kilo, I will go to the AC tons. Don't worry. Suppose you are using a 1 watt and 2 watt. What is there inside the 2 watt bulb that you are getting more lighted, more light? Why? Can you tell me? Think for a while and tell me. Why 2 watt bulb is better? What you have thought and you have answered? Tell me.
It has more power and it will give more bright light.
It has more
Power.
Okay, I need more answer. I need more answer. Tell. Let so many students are there.
Maybe it has more resistance.
It has more resistance. Okay. So when more resistance is there, do you know that whatever the loads yesterday last class I was telling about the electricity bill. When you will see the bill, let me show you my board. In that bill, you will see that how much load you have connected. My board is visible, na? Microsoft board.
Yes, ma'am.
Yes. So you will see that in your electricity bill, how much load your house has is consuming, that it has been written 5 kilowatt or 4.5 kilowatt or 6 kilowatt, like this has been written. What does it mean? Tell me. What is this power? Tell me. What is this power? What is this power? This
that much we have consumed in 1 hour.
Power consumed.
power is consumed where? Yes, answer. Power is consumed where? Where the
Load.
power is consumed? Load means what? Power is consumed where?
Appliances.
The electric
Appliances means
appliances.
what? So what are the means which part of the appliances is consuming the power? Which part? Which is consuming the power? The appliances are having, suppose I am telling you you are taking a simple conductor. Am I clear to all of you? If anybody having doubt, these are all the basic things I am discussing, don't worry. So this is, suppose I am taking a conductor which you are using in your home. Suppose you touch this conductor, it becomes heat. What does it mean? Why it becomes heat? Tell me.
And due to flow of energy, it getting heat.
Flow of energy, not exactly. You have approached the answer. I will not tell that your answer is not correct. Now, you have washed, once your washing machine operates, once your grinder operates, it becomes,
Yes,
you have touched the washing machine after operation, or
Yes, ma'am.
when it is in the operating condition, there is a heat. Yes or
And
no?
due to kinetic energy
Yes.
Why there is a heat?
and due
Yes,
to
Dale.
moving of
Friction.
energy,
Due to?
Resistance.
Yes.
Resistance.
resist.
There is a heat loss, and this loss is due to the presence of the resistance. This loss is due to the presence. Just wait, I am having some issues in my board. Just wait, I am closing and opening. This I am having certain issues in my board. Let me close it. Okay, so I want to tell you that yes, what I was telling, when you are touching any of the appliances, whether it is your laptop, whether it is your washing machine, grinder, your geyser, your iron, all these appliances which are, or fan, all these appliances, when it is becoming heat, it implies that heat is in the form of loss. Okay, or that loss is in the form of heat, I can tell. Not exactly heat in the form of loss, but that loss is in the form of heat. There is a loss. And why there is a loss? Because there is resistance in that circuit or in that appliances. That is why you are getting a loss. Am I clear to all of you? Now, in the case, in case of how you are giving the electricity bill, the electricity bill is according to the amount of loss or amount of power consumed in the resistance only. You are paying for the power consumption in the resistance only. That unit which I am telling you as watt or kilowatt, that is the unit of the power which is consumed in the register only. Am I clear to all of you? Am I clear that these basic things all of you should know?
Yes,
Am I clear to all of you?
Yes, ma'am. Yes,
So here I want to tell you that how much resistance you are using at your home, how much power is consumed in the resistance. Accordingly, you are paying for the electricity bill. Electricity bill, you are paying for the electrical energy you are consuming at your home. That electrical energy is what? That electrical energy is your electrical power, obviously multiplied with time. How much power you are consuming, that we are taking it in terms of kilowatt or watt, and time we are taking it is an hour. So your electrical energy, how much unit you are consuming, that unit is nothing but your kilowatt into hour. That is your kilowatt hour. 1 unit is equal to 1 kilowatt hour. So this kilowatt is what? This kilowatt or watt is the power consumed in the resistance only. Am I clear to all of you? Because
Yes,
Power
ma'am.
consumed in R only. Okay. So you are having different circuit elements like your inductor, your capacitor, resistor. Inductors and capacitors do not consume an active power or the real power. This is nothing but the which power? This is your real power or the active power. Details I will be discussing later on. In this first module, it is not required, but because there will be a gap in for some days, I do not want to complete the module here also. So this power is your real power, or it is the active power, or it is the true power. This real, active or true power is nothing but, I have told you, it is the power consumed in the resistance only. Am I clear to all of you? More is the resistance if you are taking 1 watt and 2 watt. So when you will see that the wattage is more, you should be very careful while using these types of load. Like your geyser, heater, water heater, steam iron, or your iron which you are pressing. So all these types of load are hitting loads.
Your voice is not clear, ma'am.
Huh?
Ma'am, your voice is not clear.
My voice is not clear.
Clear, ma'am.
It's clear, ma'am.
Clear, ma'am.
Okay, maybe you are having certain issues. Maybe you are having certain issues. Okay. So here I want to tell you that inductors, capacitors, resistors, all these are hitting elements. All these are electrical elements. But inductors and capacitors, they do not consume any power. Okay, they do not consume any real power or the active power. So we are not paying the electricity bill for the inductive load or for the capacitive load. We are only paying for the power which is consumed in the resistance only. So nowadays we were not using heaters. Are we using heaters? We are now using natural gas. Yes or no? Yes or no? We are using gas. Now we are not using heaters. Are you using heaters? Previously we are using heaters. Now we are using induction heaters. Yes or no?
Yes, ma'am.
Okay, so when you are using these types of load, these are all resistive loads when you are using like your tungsten filament lamp. Why we are using why we are not using nowadays tungsten filament lamp? Tungsten filament lamp we are not using because that is a purely resistive load. Okay, power will be lost there. Power will be lost in the form of heat. Any machine you touch it and it becomes heat implies that there is a resistance, and when you are supplying the current, there is a loss. That loss is known as I square R loss. This is a loss, and this loss in the form of heat. Okay, and this loss is this power loss is the power consumed in the resistance. That consumption of power, how you know that there is a consumption of power in the resistance? That will become heat, like your iron. It will become heat because there is a loss in the power. Understood, all of you? What is the basic concept why I am telling all these things? Got it or not? All of you understood? Okay. So that is the loss in the form of heat. When it is a geyser. Take a geyser. It is making you hitting the water. Okay. So there is a heating element obviously. And what is that heating element? Heating element is nothing but the resistance only. So when the current is flowing, it is hitting and it is hitting the water. Understood? So they are all pure. So those loads, you will see that they will your micro oven. Okay, all these types of load, if you do not know, I will give you an activity. You will find out what is the power rating of those types of load. Okay, you will see that those types of load are having very high power rating compared to your bulb, fan. Bulb is having very less, 10 wattage, 12 wattage. Okay. But if you see your geyser or your micro oven, all this carries a very high power. Understood or not? Got it or not? I am telling you. Okay. All of you? Yes. So yes. So now all these things I have explained you. Now you tell me why is AC is rated in ton? Why is AC is rated in ton and it is not rated in watt or kilowatt? Why? Tell some any of you.
Because means let's say 1,000 kilocalories of heat is removed, which is equal to 1 ton. That's why it's rated
Yes,
in.
1 ton. And why it has been named as a ton, like your Faraday's law. Like similarly, in the earlier days, in the olden days, what they were doing in order to cool, for cooling a room, they were using tons of ice. Okay, they were using tons of ice in the room for cooling of the room. From there itself, the ton has been derived. Understood, all of you?
Yes, ma'am.
Okay. So now we will go to, now all of you understood, or is there any doubt? Tell me. These are all basic things. You may not get everything in your from exam point. Everything I am not telling for the exam point of view. Many of the things I am telling you, which is important for your knowledge purpose. Okay. Everything don't relate for the exam for getting good marks. Okay, so now coming to here, this I have explained the generating station. I think I have explained this circuit line diagram. Yes or no? Any
Yes,
doubt
ma'am.
with this diagram? Tell me. Any
Ma'am.
doubt? Tell.
Ma'am, another question you have given that install capacity till date. You have given till 31st August 2021.
Yes.
Ma'am, I found on Google till 31st December 2021, it was 393.389 gigawatt.
Yes. See, so from here, what you are concluding, day by day the installed capacity is increasing. Yes or no? Day by day the installed capacity is increasing. Am I clear, all of you, or not? So day by day, when the installed capacity is increasing, obviously we are consuming more power. Understood or not? The power consumption is being more. Am I clear to all of you? Respond, all of you. Okay.
Yes, ma'am.
Yes.
ma'am.
Yes, ma'am.
Okay. So now here I was discussing about the power system layout. Here, these are the generating stations. Remember, this diagram is important. Which slide is important, I'm telling you, mark it as important. So these are the generating station. At the generating station itself, you will see that if you are going to visit near future a generating station, you will see that the generating station, at the generating station itself, they are having a step-up transformer. What is the function of using a step-up transformer? The function of using a step-up transformer means whatever the power we have generated, that power I have to transmit, but that power I have to transmit at a higher voltage. So what will be my current? If my power remaining same, what will be my current? Tell me. What will be my current? Yes, tell me. If I want to transmit, suppose I want to transmit 15 kilowatt of power, suppose 15 kilowatt. Okay, then this is what? Power is nothing but, you know that it is product of voltage and current. Yes or no? Clear or not? Clear or not? So if my power remaining constant, whatever I have generated the power, if I am increasing or if I am transmitting that power at high voltage, what will be my current? Current will obviously reduce because I have to keep this power constant. All of you got it or not? Clear or not? Okay.
Yes, ma'am.
Yes. So when my current is reduced, what happens to my area of the cross section of the conductor? Area of the cross section of the conductor, current is reduced implies A will be less. Area of the cross section will be less. So what about my conductor cost? Conductor size will be reduced. Area of the cross section is less means conductor size is reduced. All of you got it?
Yes, ma'am.
Conductor size is reduced means
Yes, ma'am.
what will about the conductor cost? Cost is also less. Cost is reduced. What about the insulation cost? Insulation cost will also be less. Am I clear to all of you now or not? Insulation will
Yes, ma'am.
also be less. So we are due to these advantages. And what about the resistance? I forget to tell you about the resistance. What about the resistance? If current is less, then what about my resistance? Tell me. Resistance of the conductor. So what if current is less? I have told you now here, what is my heat loss? There will be an I square R loss, right? So when the current conductor is having resistance and current is flowing here, there will always be I square R loss in the form of heat. Always remember it. When there is a conductor, the conductor is not a pure conductor. It is having some resistance. When current will flow, there will be a loss in the form of heat. That loss is called as I square R loss. Clear? So here another advantage of transmitting the power at a high voltage is the loss will also be less. So how many advantages I have told you? Insulation is required is less, cost of conductor is less. Am I clear to all of you? How many advantages you are getting? But it is not. Conductor size is, so due to these advantages, we are transmitting the power at high voltage. Am I clear to all of you? Okay. So yes, now, yes. So here at the generating station itself, we are having, these are all step up transformer. We are stepping up the voltage. So for transmission system, whatever may be the voltage, we are stepping to, or whatever may be the power, we are stepping to 400 kilovolt or 220 kilovolt or 132 kilovolt. These are very high voltage. Now after that, we are stepping down the voltage with the help of step down transformer. So for sub-transmission system, now we have got 66 kilovolt, which we can give it to large consumers. Large consumers means your large industries. They are large consumers. Okay. Now after that, again step down transformer. So when now we are distributing the power. So when a distribution comes to picture, we are using step down transformer. Okay. So again step down transformer we have used. This is primary distribution, where this medium large consumers like small industries, they are medium large consumers. They are connected to primary distribution, where they are taking the voltage 33 kilovolt or 11 kilovolt. Okay. Then come to the small consumers. Our houses are connected to the secondary distribution, where the voltage is 400 volt. This 400 volt is the line voltage. Okay. And because in India we are having a star connection, the phase voltage is 400 volt and line voltage is 400 volt. Phase voltage is equal to 400 divided by root 3. That is your near to 230 volt. Am I clear too? So 230 volt, somebody will ask you, you will tell that our phase voltage is 230 volt, but line voltage where our house is connected to the three-phase system, there the line voltage is 400 volt. Am I clear to all of you? Okay.
Yes,
Yes, ma'am.
So now next come to the different types of generating stations. Here we are discussing about, we'll be discussing about steam power station or thermal power station, hydroelectric power station, solar power plant, nuclear power station. Okay. So coming to an inside of a hydropower plant, what is there inside a hydropower plant? Here you see it is a reservoir where we are storing the water, and this is the dam. Okay, so that water is how the power is generated in case of hydropower plant. Tell me how the power is generated in case of hydropower plant. Tell me. This flow of water, we are passing the water, and this water is rotating this turbine. Is it? Are you able to see properly?
Yes, ma'am.
So that turbine is, you are telling previously, na turbine is generating the electricity. No, turbine is rotating. So turbine is rotating implies it. We have got a mechanical energy, because if whatever the generating station may be, we require a mechanical power. that mechanical power will be converted to electrical power, or that mechanical energy will be converted to electrical energy. So that mechanical energy we will get once the turbine rotates. So when the turbine rotates, you will see that turbine is coupled to the shaft of the generator. This is my generator. This one is the generator. This is the shaft of the generator. The turbine is coupled to the shaft of the generator. Once the turbine rotates, it will rotate the generator, because if the generator is not rotating, I cannot use the Faraday's laws of electromagnetic induction to generate the electric power. So in order to use the Faraday's laws of electromagnetic induction for generating the power, I want that all my generators should rotate, so that we will discuss later on how the Faraday's law is applicable. You already know in the 12th standard also. So the generator will rotate and it will give you the electrical power. So electrical power, I have told you, immediately we are stepping up with the help of step-up transformer. So after stepping up, we are transmitting the power with the help of the power lines. Am I clear to all of you? This is the basic working I have given you. I will give you activity to the different groups. You will show how exactly. I will give you the video link also. After I will complete this one, I will give you some video links. You will open those links and you will see how exactly the power is transferring from the generator, from the reservoir to the power lines. I will show you. I will give you the video. Am I clear how exactly basic thing, how electric power is generated from a hydroelectric power plant?
Yes, ma'am.
Yes, ma'am.
Is there any doubt? Anyone having any doubt, you are free to ask at any time. Okay, you are free to ask. You may not get much difficult question in the case of module 1. Module 1 questions will be easy, and all those are basic questions you will be getting. Okay, no problems, only theoretical. But the thing is that some basic information, basic things you should know. Now coming to a steam power plant. How the power is generated in case of a steam power plant, tell me. How the power... Yes.
Ma'am, by burning the water produces steam, into which turbine rotates.
Yes, very good. So here you see, you are burning the coal. Okay.
Ma'am, can you just hide that, ma'am? Stop sharing, ma'am.
Okay.
Can you hide that? Because it's, ma'am, hide, yes. Thank you.
Okay.
Yes.
So now here you see, this one I will briefly explain you what exactly is happening, and I will give you a video link. You will see later on. And this one I will give you an activity. Okay, you will properly explain me how exactly the steam power plant is working, telling me the details working. So here what we are doing it is, here you see the boiler is there. Okay, the boiler is there. The what is the function of this boiler? This is the cold storage faster with the help of locomotive, that is trains. They are bringing the coal to the steam power plant. Then this is the coal handling plant. Then boiler is there. It will the coal is burned. Then steam is there. Okay. Then it is, you see, steam is coming and it is rotating the turbine. Okay. After the turbine rotates, it is, you see that it is coupled to the shaft of the generator. Now the generator will rotate and it will provide you the three-phase supply. After supplying, then with the help of transmission lines, the power is transmitted. Am I clear to all of you? This is the basic thing which I am telling you. Here, all of you understood?
Yes, ma'am.
Yes, ma'am.
Yes, sir.
Now come to nuclear power plant. Nuclear power plant. How the power is generated in case of nuclear power plant? How the power
Again, uranium release the heat.
I have shown you the equation. Yes.
Ma'am, by fusion and fission.
Yes,
The
ma'am.
control
Fusion and fission. Only one, either fusion or fission, tell me. Not a
Fusion.
Fusion.
Yes.
fission. Tell me. Fusion or fission?
Fission, ma'am. Nuclear
Fission. Okay. Fission.
Yes, my friend.
Here, in the nuclear, due to nuclear fission, the energy is produced, and that energy is used to what?
To heat up the water to generate
Yes.
steam,
That is
and
the
that steam
it is
is the
used.
turbine.
Very good. It is used to heat the water, and then steam is produced. You see, the steam is rotating the turbine, and that turbine is coupled to the generator or the alternator, which is generating the energy, generating the three-phase supply or the power. Then, with the help of this transformer, it is stepped up. After step up, always you see, before transmission, we are stepping up the voltage with the help of transformer. Okay, after that it is transmitted. Clear to all of you?
Yes, ma'am.
All of you understood or not? Tell me.
Yes, ma'am.
Soham understood.
Yes, ma'am.
Yes.
Soham, Vivesh, Ankit,
Yes, ma'am.
Ankit.
Yes, ma'am.
Okay, very good, very good. So here I have just told you briefly. I have not gone to details. I will show you. I will give you the link where you will see properly, and so that you will be able to understand more clearly. And you will present also. This one I am giving you the activity, different types of generating station. Now come to the working of a solar power plant. How it works? Tell me. Solar power plant. How it works?
Ma'am, solar power converts the solar energy to electrical energy and then
Yes.
store it.
Solar energy to electrical energy with the help of which?
Solar panels.
With the help of solar panels. Solar panel. Yes, there is a photovoltaic effect. So due to photovoltaic effect, the solar energy is converted to what?
Electrical energy.
Electrical energy. But that electrical energy, remember that is in the form of DC. Okay, that
Yes,
is in the form of DC.
DC.
So that DC energy or the DC power is stored in the battery. Okay, with the help of inverter, or this is a converter. Okay, this is a converter, or we call it as an inverter. Inverter is nothing but a converter. There are different types of converter. Last class I told you. Inverter is one of the converter. Okay, so that DC is converted to AC. So now after conversion, you give it to the different appliances, because in our house all the appliances are taking AC power. Wherever a DC power is required, there we are converting it with the help of a AC to DC converter. AC to DC converter, we also call it as a rectifier. Okay, so wherever is required, your adapter is a rectifier, your mobile adapter or your mobile charger or laptop charger, all are rectifier. Wherever it is required, we are converting with the help of a rectifier. So this is how a solar power plant works. But now I will ask you a question to you now. Solar power is available. India is getting a lot of solar energy. I will tell that we don't have. We have this year we have got 4 near to 4 months. So we have got winter season. But earlier I think 1 month was 1 month is enough. Rest of the months we are getting only summer season. Okay, maximum summer season. So solar power we are getting solar power in a very large amount. So why we are still dependent on the renewable energy? What is the main reasoning behind it? Can you tell me?
Solar panels
Because it's expensive.
Yeah.
it requires large area.
Expensive? Why? No. Now silicon, now different high quality cells have come. It is not expensive. Expensive is
It
not.
is not available in most of the.
Yeah, and awareness is not there, ma'am. I think so.
Awareness is not there. Is one of the
Ma'am,
one of the.
storage of that, ma'am, energy, ma'am, like battery, we store it a battery, but it requires more area for the storage of the charge.
Okay, some of you have told some answer. I will not tell that all are incorrect answer. You have approached somewhere it is correct, but I need the more correct answer. What is the main reason? What is the main reason? Main reason for not using solar plant and still dependent on the non-renewable source of energy is that solar power plant is having very less efficiency. Okay, the efficiency is actually low. Whether you talk about a solar power plant or a wind power plant or any renewable energy sources, there the efficiency is very less. Okay, maximum we are getting efficiency near to 20%, 25%. Okay, so you will when you will read details about the solar plant, if possible, you may not be you reading computer science students, but you will see that this after research it has been observed that solar power plant is giving you less efficiency. So more and more researchers we are working on it. More research we are doing on these types of power plants so that how we can increase the efficiency of the power plant. Am I clear to all of you? Okay. Am I clear to all of you? The efficiency is less. Yes. Efficiency is less. Still, there are different factors. I need not to discuss. It will take much time. There are many factors like awareness is not that. You can use you can use the solar power plant. You can use a solar calculator. You can use in order to charge a battery. You can use solar power plant. All these types of somebody told awareness. Some awareness should be there. We should not be so much dependent on the non-renewable source of energy. We are so much dependent on non-renewable sources of energy that we are, and nobody is no awareness among these types of no awareness to the citizens of India. I want to tell you, one professor has come from I think Japan or some developed country, Japan I think. He was telling that at what time you are washing your clothes. You may not be washing your clothes. Your mother may be washing your clothes with the help of a washing machine. But you tell me, at what time your mother is working with the washing machine? At what time your mother is?
Morning time.
Morning time. Not morning, not early morning. Near to 9, 10 a.m. when you have washed. When
9 to 10.
Yes, 9 to 10. 9, 10 or 10, 11 like that. Yes or no? Whenever she will be free, whenever you have complete your bathing, everything, when she will be free, then she is using the washing machine to wash the clothes. Yes or no? You know, at the 10 a.m., the power system is completely loaded. Why? At 9 a.m., all offices are open. Yes or no? We are going to the college at 9 a.m. We are switching on the AC immediately after going to the campus. We are switching on the AC, or the switches have already been on. When you are going somewhere, you are immediately coming to your home. You are immediately switching on the AC. Yes or no? Am I correct or not? This is the practical thing which I am telling you. Okay. So here already my power system is burdened at 9 a.m. My all offices are being open. All bulbs, fans, ACs are working. Yes or no? All lifts are working. At that time, you are giving a extra burden to the washing machine where it is not required at that time. Okay, you know that in case of if your friends, relatives, or your any near dear are staying in the developed country, you ask them. They are so much concerned. They will be using. That professor was coming. He was telling that at 12 midnight or 11 midnight, where my power system is not at all burdened, at that time I am using my washing machine. Are we so concerned? No. Big no. We are not at all concerned about the power system. That is the reason why we are still getting what I can tell, power with a very bad quality, not a good quality power. Always we are getting a fluctuating power, or there is a immediately there is a power setup. You will see that there is so much of load. There are 4-5 ACs will be turned on, and immediately there will be certain disturbance. You will see that your MCB has fallen or something. Some issues are going. Yes or no? Why? Because at that time with the power system is completely burdened, and when the load is not uniformly distributed. Okay, so that professor, why I want to tell you, that professor was telling, he was telling that I am astonished that when the power system is burdened, or everyone is using those loads which is not required at that time. Okay, it is not so necessary at that time that we were still burdening the power system. We are not concerned. Should be some awareness. That he was telling that at midnight, if I am using the power, that power is given by the government free of cost. He is telling that if you will use that power at 11 p.m. or 12 midnight, at that time you can use the power without any cost. Why? Because you are not burdening the power system. Okay, why I am telling you this type of awareness is not there. You may be knowing in 2000, I have forgotten that date. There was a complete blackout in the northern area. Yes or no? You know it or not? Complete.
I think so, Mumbai, ma'am.
Not Mumbai, that is near northern. Complete blackout of the Indian, that was in the history. No, where it has happened. You can search it from the Google. 2002, I think. Complete blackout. Which year I have forgotten. That is blackout. 2000, not 2012. You know it or not?
Yes.
Who does not know? Everyone. Northeast India. Complete blackout. You know. Okay, why it is the in the history nowhere, in no country has faced how India has faced at that time. Anybody know me? Tell me that yes, I know it has happened.
Ma'am, on Google it states
30th July 2000.
30th July. Yes.
Yeah,
30th July.
30 first I have not remembered the date, but year is not 2002, that was 2012. That means recent, 10 years back.
Yes,
You
ma'am.
see so much burden we have given to the power system and it has gone complete blackout. So many states, not area, so many states were without supply for so many days. Okay, so this is how our power system, this is how we are working. I will also tell most of you are also not concerned. Okay, most of you are. You are thinking that yes, my father is paying money. Why I will so? Laga hai fan to chale. Yes, these things are doing because there is no awareness. Okay, so all these things we have to think as a future engineers. So this is how I have told you how we are working with giving the solar energy to our load. Okay, we are giving the solar energy to the different types of electric loads. Remember that we are in between the solar energy to the house, to the loads to your house. We are using inverter. That inverter is used to convert DC to AC, and that DC is whatever the power is coming from the solar energy that is stored in the form of battery. Okay, and that DC power is given to the inverter, and that inverter is giving to the power to the different types of load in your house. Okay. Now comparison between, this is the last slide I will complete and I will leave you. So comparison between the different types of generating stations. Okay, here mostly we are using thermal, hydro and nuclear. So I will compare a thermal, hydro and nuclear only. Now coming to the site, the thermal power station will be where the thermal power station is there. Their availability of coal will be there. Water and transport facilities should be there. Okay, you will see that wherever there is a thermal power station, you must be knowing about NTPC, National Thermal Power Corporation of India. Oh, okay, so where there is an NTPC, thermal power plant, there will be, you will see that the train facilities there. Train are always coming, and there coal is coming, and water and transport facility, what I have told you. The train lines will be there. Okay. So hydropower plant, possibility of large reservoir, a dam. Usually they are hydropower plant you will see in hilly areas. In Darjeeling is the first oldest hydropower plant is in Darjeeling. Nuclear, away from population center. Where there is a oldest nuclear power station, tell me? Oldest first nuclear power station in India? Anybody staying in Mumbai?
Tarapur.
Yes, Tarapur is in Mumbai. Tarapur is the first nuclear power station. Okay. Then coming to the initial cost. Coming to the initial cost, thermal power station is having lower initial cost. Why so lower initial cost? Because we are not constructing a dam like a hydro power plant. Hydro power plant, what we do? First, we have to construct a dam. That is, so initial cost is very high. Okay. Similarly, for nuclear power station, it is highest. Why? Because you have to think about a nuclear reactor. Okay. So next, coming to the running cost, it is higher than hydroelectric power plant, because always the coal will be coming, running cost will be high. Always the trains will be coming, coal will be coming. Then hydro power plant, it is practically nil. Why? Because the fuel is itself there, water is there itself. So that is practically nil. And it is minimum running cost. Why? Because you require very less amount of fuel for the nuclear fission reaction. Very less amount of fuel compared to that of your thermal power station, where you require a large amount of coal to produce certain energy. Here you require a very less amount of the fuel. So limit on source of power, very limited reserve of coal for thermal power plant. You already know, I need not to tell you. Water in reservoir is not dependable. Okay, it is not dependable, because when there will be a rain or not rain, okay, so that is it is uncertain. Now similarly, adequate amount is available. I have told you limit on source of power. I have told you very small amount of fuel is required, so you are having an adequate amount available. Now fuel transport cost, it is maximum. Always the coal has to be coming. Coal has to come through the help of train to the thermal site. Hydro, it is practically nil. Nuclear, it is minimum. Okay, because very less amount of fuel is required. Cleanliness and simplicity, it is least clean. And hydro, it is simplest and it is very clean. Nuclear, it is less cleaner than hydroelectric power plants. Okay, it is less cleaner than, but highest is clean is your hydroelectric power plant. Okay, so this is up to this. I will complete. I will not now any any doubt related to this. You tell me.
Can you go to the previous slide once?
This one.
No, ma'am. One back.
Which one?
Ma'am, before that solar panel.
Yeah.
Ma'am, no, another. Yes, ma'am. This one.
I will today. I will upload it. And this one, nuclear, thermal, and hydro power plant. This one I will give you as an activity. This one I will give you as an activity to all of you, that you will find out. You will tell me exactly how it is working. How it is working. How these power plants are working. And you know about the large, let me see, your oldest power plant in India and highest power plant, not highest, yes, having high capacity power plant in India. You know this or not? Huh? This data, you know it or not? Here you see, I want to tell you here, Hussain Sagar thermal power station, Telangana. Whoever is reading in from Telangana, it's the oldest power station, thermal power station. Vindhyachal super thermal power station, Madhya Pradesh. It is the biggest. Biggest means it is having very high capacity. Okay. That I have not encrypted in. Here you see in the for hydroelectric power plant, Koyna hydroelectric project, Humbarli, Maharashtra. Have you know this or not? You know this or not? Or you do not? You have not heard at all? Sidrapang
No, not
hydroelectric
heard.
project. Why you have not heard? You go and visit, all of you, whether it is a nuclear or thermal or hydro. You go and visit a generating station. No fees it is required. Okay, no fees it is required. You are going to watch movie, you are paying money. Here you will not have to pay anything for it. Okay, go and visit a generating station. And as a student, they will be encouraging you to visit. Okay, you go and visit a generating station. Got it, all of you? Any doubt? Tell me.
Yes, ma'am.
Today I will not discuss. Again, some days you will be. Some days there will be a. Yes, tell me. Any doubt? Tell me. Next class I will discuss about the overhead transmission line, underground cable. Okay, what are the different? You have seen a generating station. Tower, transmission tower. Have you seen these types of towers or not?
Yes, ma'am.
Yes, ma'am.
What are the different types of tower? What is this line? I will tell you, discuss. Topmost line, what is that line? What are these types of conductors? This one, how, which types of connection it is there? Okay, where the insulator is there, everything. I have put a video also. I have kept a video also. I will tell you, it will take another 2 to 3 class. In lesson plan, there is 3 class, but I will take another 2 class and I will tell you everything.
Yes, ma'am.
I will video also tell you. These are very basic things you should know. This is the underground cable. What is this cable used? What is the voltage? What is the insulator they are using? Okay. So these are for general knowledge, at least you should know. Not for an exam point of view. Let me take the attendance. All of you 86. Why 4-5 students are absent? Saurabh, you understood? Saurabh, Sayak.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Very good. Supriya, Sudipta,
Yes, ma'am.
Utkarsh,
Yes, ma'am.
Anurag, and another 2 to 3 class I will be knowing. Anvay, Ghosh, Chetna,
Yes, ma'am.
Pritish, Harsh. You are feeling bored because
Yes, ma'am. Yes, ma'am.
this is only theoretically, maybe you are feeling bored, but once I will start the DC, you will feel very interesting part. This you may be feeling little bored because this is related to only theory. But no, most of the sections they will tell you, they
We
will
are
not,
learning new things.
most
Ma'am,
of the
not,
sections,
not that much problem. Little things.
little boring.
Little boring.
Little boring because this is theoretical. Another one class I will take and I will over it. Then I will start the DC, which will be very interesting. Okay.
Okay, ma'am.
Okay. All of you leave.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Good evening, ma'am.
Good.